Hello guys, you're welcome to my channel. Today we are going to be looking at a very important topic in physics, and the topic is friction. When you talk about friction, we all understand that whenever an object changes their position in respect with a stationary object, we say that body performs what we call motion. Now, a motion is as a result of what? An applied force, because a force is what? An external agency that changes or tends to change the position of an object. So whenever the position of an object changes, that is, the body is said to be in motion, there is an opposing force that always opposes what? The motion of an object. That is, if the body decides to move forward, the force will cause the body what? To move backward. Are we together now? That force is always opposing what? The motion of an object, and that force is what we regard as friction. I'll be talking everything about friction in this video. If you are new to this channel, I kindly please subscribe to this channel, like this video, and share within your friends. And if you are a subscriber already, don't forget to comment positively and also share this video, and don't forget to give us a thumb. Now, let's see how it goes. When you talk about the importance of friction, that is the advantage of friction. Remember, we said it is a force that opposes what? The motion of an object. Right? If that should be the case, there are advantage and disadvantage of this particular force. If there is no what? Frictional force between the feet and the ground, we cannot walk without slipping. If the tire of what? Of a car is not made rough, or a bicycle or a motorcycle, if the surface of their tire is not made rough, then it will not be possible for the brake of the car to work. And the surface is made rough just to increase what? Friction. If there is no friction between the belt and pulley, the part of the machine would never what? Rotate. Now, these are few advantages of what? Friction. As it has advantage, there is also what? Disadvantage. If not for friction, machine should work 100% efficiently. And also, if not for friction, there shouldn't be anything like wear and tear in machine. That is, friction causes what? The wear and tear of machine. Friction reduces efficiency of machine. Friction also causes what? Overheating of machines. Those are some advantage of what? Friction. Now, is it possible for us to reduce friction when excess of it is not needed? Yes, absolutely. It's possible for us to do what? To reduce friction if excess of it is not needed, because excess of friction at times is a disadvantage. Are we together? Yeah, if we are together, we can reduce friction with different methods, like applying lubricants. When you apply oil or grease to the surface where you want to reduce the friction tends to reduce. When you polish what? Two surfaces, the surface becomes so what? Smooth and shine. That reduces what? Friction. We can also reduce the friction by streamlining. When you look at your plane and you look at your boats, you see that they made their mouth what? Sharp, so that they will be partially in contact with fluid. That is made in order to reduce what? Friction, and we call it streamlining. Is a method of reducing friction. We can reduce the friction of what? A sideways motion by banking, and so on like that. Those are some of ways in which we reduce this what? Friction, if excess of it is not needed. Now, we have two types of friction, and that is what? Kinetic friction and what? Static friction. When you talk about static friction, the word static is related to stationary. When something is static, it's stationary, it's not moving. And when you have what? Kinetic, that word kinetic is related to what? Motion. That is, we can consider motion in a stationary body, we can consider friction rather in a stationary body, and we can also consider it in a moving what? Body. Now let's look at it. Let's take for instance that I have a box on a surface like this, and I want to push this box. Let's say this is myself, As a matter of fact, you know, I'm kind of cute than this. But for better understanding, let's assume that this is myself. Now, if I apply force to this box, that is, if I push the box, this box might not move. If the force that I'm applying on it is not enough to overcome the frictional force there. But by the time I push it, that is, I keep adding more force. With time, you see that this body will start moving. That force that caused this body to start moving is what we call the limiting frictional force. That is, by the time I push the body, initially it's not moving. If I keep adding force to it, the body will start moving. When that body starts moving, the force that caused the body to start moving is regarded as limiting frictional force. By the time I keep pushing it, since the body starts moving already, pushing it will be more easy. Then the body will keep on moving. Are we together now? Now, as at the time that the body is not moving, the force that prevents this body from moving is known as the static friction. And by the time the body starts moving, the force that is opposing the motion of the object, because by the time you apply the force in this direction, this is an applied force in this direction, it causes this body to move in this direction. The kinetic frictional force is said to oppose the motion of this object in an opposite direction. That's to tell you that when this body is not moving, the force that is preventing it from moving is a static friction. By the time the body starts moving, the force that is opposing the motion of the object is kinetic friction. That's to tell you that the kinetic friction of a body and the static friction cannot occur simultaneously. Are we together now? When there is static friction, we cannot have kinetic friction. And when there is kinetic friction, we cannot have static friction. Do we understand that now? By the time the body starts moving, the static friction disappears. Then we have kinetic friction. By the time the body stops moving, that is the body when it's not moving stationary, we have what we call static friction. We don't have kinetic friction then. Is that taken now? Correct. If that should be the case, let us analyze the application of force on this particular body in regard the static friction and the kinetic friction. Now, if I drop this box on this surface, this box is said to do what? Is said to exert a weight force on this particular surface. Now, according to the third law of motion, action and reaction are equal but opposite. This surface is said to do apply a normal force in an opposite direction, but the normal force is said to equal to the weight of the object. Then this body is said to be at equilibrium. So as the weight of the body moves in downward direction, the normal reaction is said to do is said to move upward. And this is equal to this. Now you might be reading some material and you will see that they use the normal reaction R as F sub n. Are we together now? This is the normal force. This normal force is the force that this particular surface exerts on on the box. And mg, which is weight force, is the force that this box exerts on on this surface. According to the third law of motion, these two forces are equal but opposite. Are we together now? Now, if that should be the case, we have what we call the static friction. Static friction is less than or equal to the coefficient of static friction times the normal reaction. Less than or equals to the coefficient of static friction times normal reaction. This shows that the static friction of the static friction between two surfaces is not constant. The static friction between two surfaces is not constant. That's why we have that static friction is less than or equals to the coefficient of static friction times what? The normal reaction. Now, for kinetic friction, we have this to equal to the coefficient of kinetic friction multiplied by what? The normal reaction. This shows that the kinetic friction between two surfaces is always what? Constant. And mind you, I would like you to note that the coefficient of static friction is always greater than the coefficient of kinetic friction. These are some properties that we need to understand. And looking at this formula, you will see that what? The static friction is not what? It's not dependent on the surface. That is, the area of the surface in contact is less concerned about it. But it depends on the what? The nature of that particular surface. That is, if the surface is made rough, friction is said to do what? Increase. And if the surface is what? Very smooth, the friction can be approximately what? 0. Thus, the value of what? Of coefficient of friction always range within what? 0 and what? 1. You cannot have what? Coefficient of static friction or kinetic friction to be greater than 1. Are we together now? Or less than 1. Are we together now? Or less than 0. You can have it to be what? Less than 1, but it cannot be what? Less than 0. The value is between what? 0 and what? 1. Do we understand this now? Let us now get something clear now. I want to explain how coefficient of what? How static friction works, that is the static frictional force, and what? Kinetic frictional force, and at the same time the applied force. These are the three forces on what? On one object. Are we together now? Then, with the reaction of these three forces, then we can determine what the net force is going to be. Now, let us create a table to explain that. Let's take, for instance, that the mass of this body is 10 kilogram. If the mass of this body is 10 kilogram, the coefficient of static friction is said to be, okay, let's take it like this. Let's say the coefficient of kinetic friction is equal to 0.2, and I have the coefficient of static friction to be 0.5. If the coefficient of static friction of this body is what? Is 0.5, and that of its kinetic friction is 0.2. Now, let us calculate for what? The normal reaction. Are we together now? We calculate for the normal reaction, and we calculate for the maximum static frictional force, and we calculate for the kinetic what? Friction. Now, first of all, let us look for the normal reaction. The normal reaction is given as what? Mass times what? Gravity. If the mass of this body is 10 kilogram multiplied by gravity, which is what? 9.8 meter per second square, then we have what? 98 Newton. That shows that the normal reaction of this body is what? 98 Newton. Okay? If the normal reaction is 98 Newton, then what will be the what? The static frictional force. The static frictional force is said to be what? Less than or equal to the coefficient of static friction 0.5, then multiplied by what? The normal reaction, which is what? 98. Thus, we have that the static frictional force is less than or equal to 98 divided by 2. That will give us 49. So, this is less than or equal to 49 Newton. What this one simply means is that the maximum static frictional force is 49 Newton for this body. Now, let us now see if what? That of the kinetic frictional force. The kinetic frictional force is the coefficient of kinetic friction, which is what? 0.2 to multiply the normal reaction that we have to be what? 98 Newton. So, we have what? 98 multiplied by 0.2. That will give us 19.6. So, this is 19.6 Newton. So, let us write down this constant somewhere here. So, we have that the static frictional force is less than or equal to what? 49 Newton. And we have that the kinetic frictional force is equal to 19.6 Newton. Good. Now, I think we can now move on now. And I would like to explain this condition with what? With a table. Now let us have this table here. Let this be our applied force, and this is a static frictional force, and this is a kinetic friction, and let this be the net force on that particular object. Now watch, if I apply a force of 10 Newton on this body, what will be the static frictional force? What will be what? Okay, let's start from 0. Okay, let's take for instance that there is what? There is 0 applied force on this body. If the force on this body is 0, then the static frictional force is said to be 0. The kinetic frictional force is also going to be 0, and the net force will be 0. Why? Because once there is no applied force, there is no force that they are going to what? That they are going to oppose. Are we together now? It's only when there is an applied force that causes what? Motion, or that wants to cause motion. That is when there is what? An opposing force can arise. If there is no motion, we don't have anything like what? Friction. Are we together now? So, motion is as a result of what? As a result of force. Good. Now, let us now increase the force to 10 Newton. If I apply a force of 10 Newton to this body, what will be the static frictional force? What will be the kinetic frictional force? And what will be the net force on this body? Mind you, this is what? 10 Newton, right? But the maximum static frictional force of this body is 49 Newton. That is, the minimum force to cause this body to start moving is 49 Newton. Are we together now? The minimum force to cause this body in motion should be what? 49 Newton, which is what? The maximum static frictional force. Now, 10 Newton force that you applied is not enough to overcome this force. Thus, this body will still remain what? At rest. If this body remains at rest, what will be the value for the static friction? Remember, if the value for static friction should be 49 Newton, it shows that this body is going to move in an opposite direction, because static frictional force is greater than the applied force. Then it shows that what? The body will push you back. But that is not happening because the body is still what? At rest. Thus, the static friction will then equals to what? The applied force. So the static friction is also going to be 10 Newton. What will be the kinetic friction? The kinetic friction is said to be what? 0, because motion has not taken place. Are we together now? What will be the net force? Because this is 10 Newton and this is 10 Newton. 10 Newton minus 10 Newton will give us what? 0. Since frictional force, we oppose what? Applied force. And force is what? Force is a vector quantity. Now that they are moving in opposite direction, we take what? Their difference, and that results to what? 0. Now, let's increase the force to something like 15 Newton. If I apply 15 Newton force to this body, is it going to cause the body to move? Let's check. The static frictional force is 49. 15 Newton has not yet overcome what? 49. Thus, the body will still remain at rest. So, the static frictional force, like I explained earlier, is still going to be what? 15 Newton. Then the kinetic frictional force will become what? 0. And the net force would also be what? 0. Do we understand this? Okay? Now, let us increase the force to 50 Newton. Now, by the time the force increased to what? 50 Newton. This 50 Newton is greater than what? 45 Newton, which is the maximum static frictional force. Thus, the static frictional force become what? 0, simply because the body has started moving. As the body starts moving, the static friction becomes what? 0. Then what will be our kinetic friction? Our kinetic friction is going to be what? 19.6 Newton. Then what is going to be our net force? Since the kinetic friction is opposing the motion of the object, then we are going to have it to be 50 minus 19.6, and that will give us what? 30.4. So the net force is going to be 30.4 Newton. Are we making sense? Now, let's see something again. If I increase the force to something 55 Newton, if the force should increase to 55 Newton, what will happen to the static friction? It will become 0, because what? The body is already in what? Motion. Since 55 Newton is also greater than what? The maximum static frictional force. Then we have what? Our kinetic friction. Remember, kinetic friction will remain constant. Thus, our kinetic friction will still remain what? 19.6 Newton. So, our net force will be 55 minus 19.6, and that will give us 35.4. Do we understand this now? That is that about what? Static and kinetic friction. Now, another way in which question can be presented, or where we can also study friction in another dimension, is on an inclined plane. Let's see if we have an inclined plane. Now, we need to pay maximum attention here. If I have an inclined plane like this, and I have what? Okay, let me use red marker. I have an object on this. This angle here is angle theta. The weight of this object is like this, downward. Okay. I think it's perpendicular to this axis. Let's call this mg. Now, if the weight of this object is mg, the normal reaction of this body is said to act in an upward direction, and that is what? R. Remember, some material will use what? Fn, but I decide to use R to show what? Reaction. So, if I take this down like this, it's said to be what? Perpendicular to this surface, like this. So I have it to be perpendicular to this surface. So if I take this to this place, here and here is said to be what? 90 degrees. What will be the value of this angle? The value of this angle is said to be this theta as well. That is, this angle here is said to be theta. How? Let's take for instance, since we see that this one is perpendicular to this plane. Now, if this is perpendicular to this place, if this one is theta, here is going to be what? 90 minus theta. Now, this particular one is also perpendicular. Now, if here is 90 minus theta, and this place is what? This place is 90. Then, the total value here is said to be what? 180. So, in order for this to be 180, this is going to be what? Theta. Do you understand this now? Because by the time I had 90 minus theta plus 90, that will give us what? 180 degree. The only thing that can make us to give us 180 degree is only if this place is also what? Theta. Do we understand that now? Thus, this angle is equivalent to this angle. Now, if that should be the case, let me now consider this triangle itself like this for better understanding. If I consider this triangle, here is angle theta, and here is the weight of the object, mg. Here is the vertical component, and here is what? The horizontal component. Now, let's take for instance that I want to know the value for my vertical component. Remember that this body, the normal reaction is what we have along this axis. That is, along this y-axis is the normal reaction. So let's get the value for that. Now, using the SOHCAHTOA, we know that this is going to be what? Cos of theta is going to be adjacent over the hypotenuse. So we have what? mg cos of theta to equal what? Y. Now, because this body is not moving, remember, this body is not moving in y direction. That is, this normal reaction is equivalent to the what? To this force here. That means the net force along this y-axis is equal to what? 0. If the net force along this y-axis is equal to 0, then R is set to equal to what? This particular force here. So our R is going to be what? mg cos of theta. Am I making sense? Okay? Now, the body is now what? Moving in this what? In x direction by a gravitational force, Fg. Now, let us determine the value of this particular point here. So the value for x is going to be what? Mg sine of what? Theta equal x. That is so opposite over what? Hypotenuse. So we have this. So this particular point here is mg sine of theta. Now, the gravitational force that caused this body to move along this x direction is parallel to this. Now, since this is parallel to this, then Fg is said to equals to what? Mg sine of theta. Do we understand this now? Okay? Now, if this should be the case now, we can now what? Move on. Before we move on, let's quickly what? Summarize what we have. The Fg is equivalent to what? The kinetic what? Frictional force, because what? This body, okay? Fg is equals to what? The applied force, because that's the force that causes this body to what? To slide down. Whereby the kinetic frictional force is opposing what? Opposing its motion. We are getting there. So this is equivalent to what? Mg sine of theta. And also, if this body is now static, then this one is said to equals to what? Fs, which is what? Static frictional what? Force. Now, the normal reaction R is said to equal what? Mg cos of what? Theta. Now, I would like us to recall that the coefficient of friction is equals to what? F all over what? The normal reaction. So, the coefficient of static friction is going to be what? The static frictional force, which is equivalent to this. We have this to become what? Mg sine of theta divided by the normal reaction, which is what? Mg cos of theta. So Mg can cancel Mg. Then we have that our coefficient of static friction is tan of what? Theta. Because sine theta over cos theta is equals to what? Tan theta. So let us note this. Okay, if we get a better understanding of this, then let us elaborate on this now. But before I go on, let's quickly summarize what we have, what we've done so far. So Fg is equal to what? Mg sine of theta. Then we have our normal reaction to be Mg cos of theta. Then the coefficient of friction is going to be what? Tan of what? Tan of theta. So let's quickly memorize that, and I think we know how we got that. Now, let us now take for instance that they ask us to calculate for the acceleration of the body. How do we go about that? Let's see. Okay, let's say we have what? An inclined plane like this. And here is an object on this particular body. So this body is said to move in what? In x direction. Then we are asked to calculate for what? For the acceleration of this body. If we are asked to calculate for the acceleration of this body, remember this is what? The frictional angle theta. How can we get the acceleration of this body? Since the body is not accelerating vertically, the body is accelerating what? Downward in what? In positive x direction. So we have that the summation of the forces along the what? X axis is equal to what? Now I will consider this body in two ways. I will consider it as a result of what? Frictionless body. That is, if the body is having what? Zero friction. If the body is having zero friction, how do we calculate for what? The acceleration. And I will also consider this body when it is having what? A friction. It means we are looking at it in what? In two ways. Way one, if this body has what? No friction. That is, if there is no friction between the two surfaces, we are asked to calculate for the acceleration of this body. Now, the only force that causes this body to move in this direction is what? The force of gravity, Fg. So we have that the summation of the forces along the horizontal axis is equals to what? Fg. And from our previous slide, we have that Fg is equals to what? Mg sine of theta, right? So this one is going to be what? M multiplied by what? The acceleration along the what? X component from the second law of motion. F equal what? Ma. So this is then equal to what? Fg, which is mg sine of theta. Are we there now? So mass, we cancel what? Mass. Then we have that the acceleration is equal to what? G sine of what? Theta. This to tell you that what? If the frictional force between these two surfaces, if the frictional force between the two surfaces is what? Is 0, then the acceleration is not depending on the mass of the body, but depending on what? The frictional angle. Are we there? So now that we've seen that what? Ax equal what? G sine of theta, this is the acceleration in this direction. Are we together? Now, before I go, like I mentioned earlier, this acceleration, when this body is what? Is what? That is when the frictional force between these two surfaces is 0. When this is what? If it is frictionless, get it clear. If it is frictionless, then the acceleration is not depending on any other thing than what? The angle of what? Inclination. So, if you want the body to accelerate more, you consider the angle of inclination. If you want it to accelerate low, you consider what? The angle of inclination. The mass of the body doesn't matter. Do we get that now? So, let me call this one equation star for a body, the acceleration of the body, if it is what? Frictionless. Now, what if there is now frictional force? If there is frictional force, what will be the acceleration? Now, you have to understand that the body is not accelerating in this vertical direction. So, forget anything about vertical direction now. Now, if the body is sliding downward with what? Force of gravity, the kinetic frictional force is going to what? Opposite. It's just a simple logic. If there is friction, we've considered the case when there is no friction, right? If there is friction, this what? Frictional force is going to oppose this force of gravity that causes this body to move in this direction. So it's going to move in this direction now. So the total force along the horizontal component now would now become what? The force of gravity minus what? The kinetic frictional force. Because if this body still slides in this direction, that shows that the force of gravity is greater than the kinetic friction. But if the body moves to this direction, it means the kinetic frictional force is greater than what? The force of gravity. But we are told that the body is moving in this direction. So Fg is equals to what? Minus what? Fk. Now the summation of the forces along this horizontal component is therefore equal what? Fg minus, what is the value for our what? The value for the kinetic frictional force, sorry, the value for the kinetic frictional force, remember we have that Fk is what? The coefficient of kinetic friction multiplied by what? Normal reaction. So we bring that here, the coefficient of kinetic friction multiplied by what? Normal reaction. So here we have that the summation of the forces along the horizontal component is therefore Fg. What is the value for our Fg? That is what? Mg sine theta. So we have this to be Mg sine of theta minus the coefficient of kinetic friction. Our normal reaction is given as what? Mg cos of theta. Is that not? So we have this now to be Mg cos of theta. Now, Fx from the second law of motion is given as what? Ma sub x to equal what? M into brackets what? G sine of theta minus what? The coefficient of kinetic friction times G cos of what? Theta. So you see now that mass will cancel what? Mass. So I can then say the acceleration along the horizontal component when there is what? Friction is equal to g sine of theta minus the coefficient of kinetic friction g cos of theta. In a nutshell, ax is equals to what? G into what? Sine theta minus the coefficient of kinetic friction cos of what? Theta. Now, if you look at this now, you will see that the acceleration is still depending on what? Only the angle. Is yet not depending on what? Mass again. Either it is what? Friction, or it is what? Frictionless. The acceleration is not depending on what? It's not depending on mass, but always depending on what? Angle. You might be asking me that, what about what? Coefficient of kinetic friction, is it not depending on it? Remember that coefficient of kinetic friction itself is equivalent to what? Tangent of theta. That is also depending on what? Angle. Thus, this one, acceleration, is also depending on what? Angle only. Now, I think we all understand this now. If that should be the case, if you are new to this channel, kindly subscribe. If you are old subscribers, drop your positive comment, give us a thumb, and stay tuned for us to tackle enough questions on this concept. Do have what? A nice day.